Hi everybody, welcome back to this course on internet technologies. I'm Vardan and today we'll be studying about routing methods and routing tables. So let's get started with how a packet actually reaches its destination. There are two possibilities. Direct delivery happens when both the source and destination are on the same physical network. This could be a host communicating with another host or a router delivering a packet directly to a host within its connected network. And indirect delivery happens when the destination is located on a different network. In this case, the packet travels through one or more routers, and at every router, a routing decision needs to be made, deciding which path the packet should take next. Since routers typically have multiple outgoing links, each one must examine its routing table and choose the most suitable path based on destination address and routing information. One of the most simplest and most widely used routing methods is called next hop routing. In this method, a router doesn't need to know the complete path to the destination. Instead, it only keeps information about the next hop. So, the immediate next router to which the packet should be forwarded, that is the next hop. This makes routing decisions fast and keeps the routing table compact. So when a packet arrives, the router checks its routing table for the destination's network address, and instead of listing the entire route, it only specifies the next hop router's IP address. That next router repeats the process and so on until the packet reaches its final destination. And this method is widely used in the internet for both efficiency and scalability. Another common method is network specific routing. In this case, the router's decision is based on the destination network address, not the individual host address. For example, a router might have an entry that says for any packet that has to go to 192.168.1.0/24, forward it to the next hop X. This means that one routing entry can efficiently handle routing for an entire network segment, which could contain hundreds of or thousands of hosts. It simplifies the routing process and keeps the size of the routing table manageable, especially important in large networks like the internet itself. Now let's look at host specific routing. Unlike network specific routing, this method makes routing decisions for individual host addresses. For example, if a packet is going to 192.168.1.10, the routing table might have an entry directing it to a next specific hop different from other packets on the same network. This allows for precise control, and it's useful in cases like routing traffic to backup servers, redirecting sensitive data streams, or managing specific host based policies. And however, this method isn't scalable for large networks since each host would need its own routing table entry, and that's why it's only used for special cases in critical infrastructure setups. And if you're confused between next hop and host specific routing, let me clarify that the next hop routing is a way of forwarding. It applies to how you physically forward the packet, whereas the in network host or default routing, it's about how you match the packet to a table entry. The last method is default routing. So what happens when a router receives a packet but its routing table has no entry for the destination network? So instead of dropping the packet, it forwards it using a default route. This is kind of catch-all entry, typically pointing to a gateway router, usually the organization's connection to the internet or a larger backbone network. And in routing tables, this is shown as 0.0.0 goes to next hop. This means that any destination not explicitly listed in this table should be sent to this next hop. It keeps routing tables efficient and ensures that stray or unknown traffic has a path to follow. So all these routing decisions depend on what's stored in the routing table. A routing table contains a list of routes, each specifying a destination network and the next hop to reach it. So there are two types of routing tables. Static routing tables are manually configured by network admins, and these routes stay fixed unless manually changed, and it's simple to manage in small or stable networks but not flexible in dynamic environments. And dynamic routing tables use routing protocols like RIP, OSPF, or BGP to automatically learn, exchange, and update routing information between routers. If a router fails, dynamic protocols quickly adjust to find alternative paths, and in modern networks, static and dynamic routing are often combined to strike a balance between control and adaptability. So let's finally look at what's actually inside a routing table entry. Each entry typically has a subnet mask, which defines which part of the destination address is the network portion. The destination IP address, that's the IP address of the target network or host. The next hop address, that's where to send the packet next, and a set of flags. So U means route is up and active, G means use a gateway for this route, H means this is a host specific route, D means it is dynamically learned, M means it has been modified by a routing protocol, and finally the interface, the router's outgoing port or interface to forward the packet through. So all of this information helps the router make fast, efficient decisions about where to send each incoming packet. So with that, we have come to the end of this lesson, and in the next lesson we'll learn about some common interior and exterior routing protocols. So thank you for joining in, and I'll see you next time.